Hello. Thank you for choosing us to provide your smart office environment and intruder detection system. I would like to explain to you the list of features that we have included to your specification. The system has a light and temperature sensor to detect whether somebody is in the room, the light levels of the room, the temperature of the room, and adjust these according to user inputs. You can set the temperature manually by using the thermostat. It's a set temperature set point. The temperature can also be controlled manually using a toggleable switch. So if the room is too cold for your liking and you do not use a thermostat, you can just turn it on with a regular switch and turn it off to save power. The light system has an automatic function where it can be turned on via a sensor to detect if somebody is in the room, and then therefore turn off when they leave the room to save power and save energy. The system has a remote and local interface. The interface is displayed on an LCD screen and is updated roughly every second. This screen shows the temperature values, the thermostat values, and the light level in the room. It can also be accessed remotely for the more tech-savvy members of the company via MQTT messaging software, of which displays a updated value every roughly 10 seconds, which can be monitored from home and locally in the office. The system comes with a security feature where if outside of office hours, if the security system is armed, any detection of light difference or somebody in the room will alert the security system, of which can then be monitored and the police can be called or an alarm triggered. This can be enabled or disabled remotely according to your wishes.
Hi, welcome to the video presentation for the code part of the project. We have Kyle Microvision here, and I'll explain what each of the files do in a sort of brief and reasonable way, because most of it's already been shown in the report. Main.c initializes the entire program. This starts the kernel, and it also initializes the app main thread. The app main thread initializes the other ones. However, this one configures like the clock and all that sort of stuff. App main has all the different threads here. These are the different functions, and down at the bottom here, this is where it starts them. These are started here and are run simultaneously in the thread viewer. This also initializes the message queues, of which pass information around the system. Down at the bottom here, we have the button press detection. RunMQTT is a thread designed by Alex Shenfield with a little bit of modification by myself. This one publishes the messages in the message queue to MQTT Explorer, which is a message broker. On here, we are connecting to the server mosquito.org. We are currently using port 1883 instead of 8883 because 8883 is the TLS certified version, of which is quite unreliable, and for prototyping purposes I prefer to use 1883 on the non-encrypted version. If this system was to be used in further stages of development when I sell it to your company, we will use TLS encryption to make sure people can't hack it. However, in prototyping stages it's pretty hackable and you can probably turn the system off online. This is something which will be developed further in the prototype stages, yes. The other thread we have here is the sensor thread, and this thread here, what this does is this takes environment data from your office and processes it to display on a screen. We have all the pins here which enable these defining what type of pins they are. Pin A0 is a thermistor, pin F10 is a thermostat, etc., etc. This initializes the pins and says what they do. The GPIO output says the LED is an output and these are inputs, blah, blah, blah. These define the message queues, of which are defined externally in the rtos file, header file. These are the button flags which are declared here. These are all the different message queues. We have 3 of them. The MQTT sends the messages to MQTT from the sensor thread. This one receives the messages from the sensor thread in the actuator thread and displays them on the screen, which is part of the integral display requirement. And this one here takes the data from the MQTT server and brings it back to the display. So as a form of feedback. These down here, these typedef structs, are the message structures, and you'll have the message MQTT thing, and that will have a thing called counter, a thing called temperature reading, and a thing called thermostat reading. These are the ones for the LCD screen, and this is the one for the feedback. Where were we? We're back in this one, right? Down here we just have a bunch of integers which are declared for other things later on. This part of the code here determines the temperature from the temperature sensor. The TMP36 has an issue where it has a 0.5 volt offset. So what we do here is we convert the thermistor reading from the analog to digital converter, of which converts a 3.3 maximum voltage to a 4095 digital value. So this line here converts it back into the voltage on the pin. This equation is found from the TMP36 datasheet and then converts this DAC reading into the actual temperature observed in the room. This here is part of the debugging process. These are all printed to the debug viewer solely for debugging purposes and to make sure everything's working correctly. Down here, this is a part of code to detect whether the button has been pressed to turn it into manual or automatic mode. When the button has been pushed, it is toggled into manual mode, and when the button is not pushed, it is in automatic mode, which saves power. This section here is part of the the automatic light section. This one is quite useful for saving power and saving energy and money in your office. If somebody is in the room, the lights will turn on automatically, and when they leave, the lights will turn them off. No longer will you have somebody leave the office on a Friday night and come back and find all the lights are still on. This works by detecting someone within proximity to the detector for the sensor. If somebody is within a certain range of the LDR sensor, the system detects there as a person nearby and turns the lights on automatically. A variable called timer is set to the maximum timer value of which can be changed in the code, so you can change the length of your timer. Whilst somebody is still in front of the system, the timer remains at the maximum and the lights remain on. However, when somebody leaves, the timer starts to decrease. The timer starts to count down from whatever it is to 0. Currently, I think we have it on 10 seconds. And when the timer reaches 0, the lights are turned off again in the room, therefore saving power. The thermostat temperature is also controlled automatically. When the thermostat temperature is above the temperature in the room, the heater automatically comes on to raise the office to a certain standard, to a certain heating level, and when the temperature reaches that value, it is shut off to save power. The minimum value this is at is 0 degrees, which allows for frost protection in the winter, when you can have your office set to roughly, 10 degrees, which then prevents frost damage to the exterior of the building because the office is cold and it will crack the bricks. This part down here is the code for the manual operation of the lights and heating. The lights and heating are controlled manually by enabling the manual switch, and when that is on, the potentiometer there in the middle, when that is above the midpoint, it is like a switch being on, and it turns both the heater and the LEDs on, so the lighting system on. And when it is below the midpoint, it turns them both off. Ideally, in a further stage of prototyping, these would be controlled separately. However, I am out of components, and I only have one left, which therefore they're both being controlled by the same thing. Below down here, we have the message queue structures, right? This takes the information from the sensors and sticks it into a message queue, of which is then passed around between the different threads. We've used different threads to make it easier to remove delays between things. The second one is this is the one to the MQTT thread, and these get published to MQTT Explorer. And these ones here are the LCD messages, and these get published to the LCD thread. At the bottom here, we have a delay slightly to reduce the frequency of messages being sent to MQTT, because if you send them too fast, it breaks and the board can't keep up with the speed that the messages are being published. Therefore, to avoid disconnects, we have a 10-second delay between message updates, which is perfectly fine for a remote office monitoring system, because if you're not in the office, you don't particularly want an update. You don't really need one every second. You can make do with roughly 10 seconds, and that reduces your internet bandwidth costs. At the very end here, here we have the command which publishes them into the message queue, and here we have the other one which takes them into another message queue. The sensor data is updated every 1 second, which reduces the strain on the system, but also provides a quick and fast response. The final thread is the actuator thread. This actuator thread here is controlling the real-time clock and the LCD screen. If we go through the code quickly, we have the initialization code for the LCD. We have the the message queues. Right, so this message queue here is from the feedback system from the MQTT thread. and this one here is from the sensor thread. So the feedback data comes from this one, and the sensor data comes from this one. This is the initialization code for the real-time clock. When this code runs, it gets the time and date from the RTC, and then proceeds to print the header message for the file, which is the environment monitor by Connor Tyler thing that comes up every time. The system then retrieves the data queue. It retrieves the system data from the sensor thread and the feedback thread. This section here makes sure the system returns back to the green standard setting if the alarm's not triggered, because the whole system gets cleared at the bottom here, and we need to make sure that comes back. The rest of this just takes the LCD messages from the sensor thread and then prints them to the board on the set lines. These are updated every second. The rest of this one here takes the feedback message from the MQTT thread to test whether the intruder detection has been triggered remotely or via the board, whether it's enabled or not. The delay in these, there's a couple reasons this delays here. The first one is it reduces the speed of the updating, and it adds a little bit of delay between the messages updating, because if they update too fast, sometimes part of the message can disappear. This is the detection for the security system. This is for the enabling and arming the system. If the message feedback from the MQTT thing is positive, it prints the message, otherwise it does not. This here prints the timer for the timer system, and that takes it from the other thread. This final bit of code here is the alarm triggering. If the message feedback saying the LED to indicate the armed thing is positive, and it detects as someone in proximity, it changes the color of the screen to red, which is quite a nice little indicator, and prints the alarm triggered code. This thread does not have a delay, which is going to disappear. This thread does not have a delay and is solely based on the speed of the updates from the other threads. Thank you.
Hi, this is the continuation for the video for embedded systems. My hands are a bit shaky, I can't really stop that. But here is the technical demonstration. So upon running the program, we see the debug window confirming whether or not it can connect to MQTT server. In a couple of seconds you'll see it should succeed, there we go, and you'll see the debugging information start to appear. This information has been put on there to just test for errors whilst in the programming. Over here we have the LCD display. It's currently in automatic mode, which means the thermostat controls the temperature and the automatic lights are used to save power. This screen updates roughly every second with the new updated data. We have the real-time clock at the bottom, and we have the light level in the room. The light level in the room does change, so with the code I have to change it manually to make sure, because at this time of night it's sort of like 9:15. The room's quite dark because obviously we don't have the window open and we don't have the light through the window, which in the daytime the light level can be up to like 150. However, at this time of night it's rather low. To demonstrate the thing working, we have the thermostat down here, which is this potentiometer, and by turning this here we'll see that the thermostat temperature increases or decreases based on how I twist it. So we currently have this on about maximum, and so we can see the thermostat is higher than the room temperature, which means the room's very cold, and the corresponding heating LED has raised up, and by turning this thermostat back down again we will see that the thermostat goes off when the temperature in the room is higher than the thermostat. I have accidentally triggered the timer system, which is a perfect thing to show you. The light level in the room determines whether lights are on. If somebody is in the room, we can save power by turning the lights off when they leave. So to detect if somebody's in the room, we use the LDR, which is the thing right in the center there. Okay, I've done it again. You see it's a little bit sensitive because obviously the room thing changes. If we give it a second, it will reset back to there. Okay, so the light on the very right is the timer and light LED. And when somebody walks into the room, what will happen is a timer variable will be set and then start to decrease when the hand moves away. So we'll have a look here. I'm going to cover this up, and the light comes on, right? So it's detected there's somebody in the room, and when somebody's in the room, the lights are on because you need them to work. And this timer bar appears, and upon me removing my finger, the timer will begin to decrease to symbolize that nobody's in the room. If somebody comes back into the room, it will reset back to normal. And then once my finger's moved away and the person is left for a decent amount of time, the light shall turn back off to save power. Here we go. Fantastic. Now, another thing is manual control of the heating. Manual control of the heating is done by pressing this button here, which I will move if I was going to do an actual control panel, because this is a bit of a mess. But upon pressing this, the thing changes into manual mode, and both the heater and the LED, aka the light system, are controlled by this potentiometer here, which I can't really get to. Basically, this has been used because I've run out of switches, but upon turning it over 50%, the lights will turn on, or should turn on, which they're not doing. Let me give me a second. Yeah, there we go. Below 50%, the light shall turn on, indicating a switch. This is meant to represent like an on-off kind of light switch. However, yeah, I'm out of switches, so we're going to have to use this. Over 50% is on, under 50% is off. This is manual control of the things. These should be able to be controlled separately, but I'm out of components. Pressing this again turns them back into automatic mode, which then the thermostat can also control the heating, which should come on there, and the lights turn back to automatic mode as well. There we go. So another feature of this is the security mode. Security mode is the intruder detection. Upon pressing the arm switch, which is this LED here on the switch on the right, it turns it into security mode. However, this has got to connect to the internet to work, so we are waiting for an update because it updates every 10 seconds. And fingers crossed, if you connect, yeah, there we go. The security system is armed, and what this does is that LED there turns on to indicate the security system is armed. And similarly to the light system, if someone is detected in the building by covering the LDR up, the system will go into security mode and publish or on the screen it will say there's an intruder. So covering up the LDR here, you'll see it turns into intruder detected mode, and that can be detected. You can like ring an external alarm like a burglar alarm, and possibly just lock the building doors and things. And removing that, the thing turns back into normal operation. We also have the feature of having remote access and remote monitoring of the system. We have the local stuff on the board, however, you can also see when you're at home, you can connect via your phone. So we are currently using, I'm going to have to work out how to hold this, we're currently using the MQTT Explorer system here, and if we go into the Connor Smart Office thing, you can see the rough uptime, because each time it updates is every 10 seconds. It's been running for roughly 5 minutes, and the temperature and thermostat are published up to here for remote monitoring. So we can see that currently the system temperature is, or the room temperature is 18.9 degrees, and the thermostat is 21.5, which means that the LED should be on, of which it is. Another thing we can do here is we can do remote control of the security system. So by publishing off to this topic down here in the security system, which I need to off, by publishing, I need to capitalize that, sorry. My keyboard is not working. Alright, so publishing off, you'll see, I'll click this, you'll hear me click it, and the middle LED, which represents the security system, will turn off. There we go, and that will disappear off there. So we have remote monitoring and remote access of the system.